we're glad that you're here. We use JavaScript to pros. We'll pay you. Okay. So there's two main talks tonight. I'm going to give the first talk, and then Jared's going to give the second talk. This is Jared. And so the talks are on ClojureScript, and my talk is, they're going to be different talks as far as orientation. So my talk is going to be like, conceptually, what is ClojureScript, and specifically, why should you use it? My talk is not code heavy, and I don't discuss syntax, and I don't discuss libraries. So there's very little tangible information that you're going to get from my talk, but you are going to get lots of ideas. So open your minds, get ready. And then Jared will be much more realistic, and he will tell you how libraries work and how you can actually do things in ClojureScript. I do promise that I do things in ClojureScript, but we just decided to break up the content like this, and I think it's going to work well. Also, I'm going to try to keep this talk at under an hour, hopefully 45 minutes or so that we have time for Jared. Okay. What just happened? Did I do that? Oops. Okay. Does this work? Is this plugged in? Yeah. Okay. So I think that's all the announcements, and I'm gonna start. Can everyone hear me in the back? Yeah. All right. Did we figure out what's going on? Where's Sean? Did we figure out what's going on with the full screen, or just this is good? Can everyone see this? Chris Pounds, can you see it? Yeah, sing it. Don't worry about it. Don't worry about it. Does this work? This doesn't work. Oh, it works. Okay. Yeah, so you can tell him what you're doing. So he's setting, so you can request full screen, right? This is a new HTML5 thing. But in order to request full screen, it has to be from a user event, right? Which makes sense because you don't want a pop-up to request it. So he's document to unclick, like he's forcing, yeah, we're going to request full screen. Sean is pretty cool. He works with pros. Oh, look at that. Okay. And then can I plus it? I can make it bigger. And then refresh. Oh, okay. Sorry. Don't worry about it. Okay. Why ClojureScript? All right, so I'm going to tell you the goal of the talk. I'm going to give you some definitions so that we're all on the same page. I'm going to talk about why you would even consider a language. I'm just going to try to talk about languages generally. Then I'm going to specifically tell you why you would choose ClojureScript. Then I'm going to finally tell you why you shouldn't choose ClojureScript. And then I'll stop talking. Okay, so this is this is too small. I can't see the title. Goal. Okay, so the goal of this talk, and I'm going to try to convince you that ClojureScript is an excellent language choice for UI development. Right? Pretty simple. But it's my goal to convince you of this. So this is going to be, what's the word? Preachy. Preachy is the word I'm looking for. Okay. So definitions. Are we all talking about the same thing? Right? Are we all talking about the same thing? Nouns are very important, right? Every language and platform and ecosystem has nouns with meanings and definitions, and we need to be on the same page about this stuff. Okay, so these are a list of Clojure concepts, and when you're reading through Clojure source material and as well as how to learn Clojure and what is Clojure, you're going to see these talked about all the time. So I'm going to try to put some definition on it. I want to say up front that I did not invent these, right? And these are really coming from Rich Hickey and David Nolan and some other really amazing people in the Clojure community. So down here I've linked to the talks where these are really expanded on. And if this page interests you at all, or these concepts interest you at all, I would just strongly recommend reading these or watching these talks. Rich Hickey is the creator of the Clojure language. He's a really brilliant guy. And even if you never write Clojure in your life, you'll benefit from watching these talks. So, okay, so the first idea is the difference between something that is simple and something that is easy. Right? So these two words, or the meanings of these two words sound similar, right? Like, oh, that's simple, that's easy. I think people use these words interchangeably in their life, right? But they're different. So let's make that distinction. So something that is simple, oh, I need my notes. I put this down, okay. Overview. Thanks for coming. Okay, so simple means something that is not connected to another thing. All right? Simple should be an objective meaning. Objective meaning. Something you look at it, you say, okay, that thing doesn't depend on anything else. I understand it completely within its context. That is something that is simple. My favorite example of something that is simple is like a cup, right? Like a coffee cup. You could take a coffee cup and go back 100,000 years and find an anatomically modern human and show it to them in like a river and they'd figure it out, right? A cup, you don't have to speak the same verbal language to know what a cup is. A cup is simple. You might say a cup is complected with water or liquid, but you're really just kind of splitting hairs, okay? So if that's what simple means, then what does easy mean? Easy means at hand, right? So easy is always a relative term. Easy for who? When? Easy in what context? So I'm real familiar with Ruby on Rails, and Ruby on Rails has all these conventions. And like, so I see a URL, and like, where did that come from? Oh, I know exactly where it comes from, right? It goes in this folder in that file, right? Because that's a convention, and I know that. It's easy, it's at hand, right? For somebody who's never used Ruby on Rails, like, where's the URL from? I don't know, right? Because it's dependent upon these contexts and these conventions. So easy is always a relative term. A good example of something that's easy is spoken language, right? So I cannot speak Japanese, not a single word of it. But there's a whole country of people that can speak it, and they don't have to think about it, right? So speaking Japanese for people who live in Japan is very easy. It's very hard for me and easy for them. So I hope we've kind of made a distinction between things that are simple and things that are easy. Obviously, the implication here is that you want to be using simple things, right, in your software, and that you're not. You're doing easy things, right? Doing easy things. So, all right. So complecting. So you can probably figure out what complecting means. It's a verb, and it means to make something complex, right? So kind of also these definitions sort of build on one another, right? And they'll build throughout the talk. So if I I said earlier that a cup might be complected with water or with liquid, right? So I'm taking these sort of two ideas and I'm combining them. So that's what complecting is. So think about this in the context of software, right? Well, I'm taking this object and I'm gonna complect it with the database. ORM, right? Or I'm gonna take this if statement and I'm gonna complect it with the DOM. If div is hidden, do this thing, else do this other thing. Now this if statement, the control branch of my program, is dependent upon the DOM state. Right? I complected these two things. And I'm going to say complecting in this talk a lot. Because you're all complecting. Okay, artifacts versus constructs. So this is a little opaque, right? Artifact is the result. It's the product, okay? And the construct is the way in which the artifact is produced. So if you're writing JavaScript, the JavaScript resultant file that you ship to the browser, that's the artifact, right? The way you write it is like when you're typing. So if you're doing like CoffeeScript or TypeScript or even just JavaScript, right? The ideas in the construct are distinct from the artifact, okay? So customers only care about the artifact, right? And the artifact has properties that customers care about, like features, speed, reliability, right? And maybe your construct is related to those artifact conditions, but maybe it's not. Right? So programmers are in love with programmer convenience. Like, oh, it's Python, and like white space is significant, and I don't have to worry about the semicolons anymore. Or is that Python? Yes. Yeah, right? Oh man, that's so easy, right? The customer does not know or care, because it does not impact the artifact. Right? So I think a lot of programmers are making construct decisions, and we should only be concerned with artifact. I'm not saying that programmer convenience doesn't matter. I'm saying that it only matters relative to its output on the artifact. Right? Construct for sure. Yeah, don't choose programmer convenience over program reliability. Bad trade-off. Right? Bad trade-off. Okay. Incidental complexity versus problem complexity. My coworkers are sick of me telling them about this, right? So, yeah, here's his hand. Problem complexity is any complexity inherent in the problem you're trying to solve. And incidental complexity, or sometimes called accidental complexity, is any complexity that has nothing to do or is orthogonally related to the problem complexity. So this is similar to artifacts and constructs, right? So like, the customer doesn't know about your database, right? They don't know. They just know data on screen or data not on screen, okay? So you want to be, every time you get a problem, every time a problem comes through, the first thing you should do in your mind is say, okay, is this problem complexity, incidental complexity, or are they complected? Is this a problem with both, right? Like, are we throwing Oracle database errors to the screen, right? And now we're like complecting problem complexity, which is like some error, right? With like the incidental complexity of how Oracle treats the errors, right? That's maybe not the best example, but we are We are obsessed with incidental complexity, right? I think that as a culture, a programming culture, we're completely obsessed with this. And I like to use this phrase, technical solutions for technical problems, right? I hate that, okay? I hate it. And the programming world is just obsessed with, here's this technical solution to this technical problem I'm having. No, we should be fixing the real problem, right? Fixing the real problem. By the way, I'm not saying that there's no technical solutions. I'm not saying all technical solutions are bad. Sometimes your problem domain is in the world of tech, right? Like if you're like a library producer or that kind of thing. But just the ability to distinguish between those two things is very important. And you want to ruthlessly guard against dealing with incidental complexity. You want to isolate it. Okay, but we have to deal with complexity. That's our job, right? Like we're dealing with this complex thing. So what are some fundamental notions of human complexity, right? So who has ever like been in the zone programming for a weekend or a week, and it's just like you are head down, and like 2 or 3 days later, oh my god, like it works, and I've written a mountain of code. Like, who has done that? Who has written a mountain of code, right? When you're in the zone, okay? So the best analogy for this is juggling, right? Your mountain of code could be thousands of lines of code. Think of these as like balls of complexity, right? The average juggler can, and again, this is like a Rich Hickey thing, right? I didn't invent this analogy. The average juggler can juggle like 3 balls, right? The best Cirque du Soleil juggler in the world can do like maybe 9 balls, maybe 12. But no one's doing 20. No one's doing 100, right? My point is that no human can take, we grow these mountains of complexity, these mountain programs of complexity. There's not a single human that can put that context into their head, right? But you have to deal with the mountain because that is the product, right? So you want to add a feature to it, or there's a bug, so you have to go in and you've got to fix it. So you go into this mountain and you pull out the ball where you think it is, but it's connected to all the other balls, right? Well, I hope you haven't complected too much, right? I hope that if you're looking at this ball of complexity, it's only connected to enough balls that you can fit inside your head. Because if you can't, you don't really understand your program, right? And understanding your program, understanding complexity, that's the heart of what we're doing, all right? I don't care how much testing you have. I don't care about how good your QE is. If you can't understand how your program works, how can you tell me that you're going to fix it, right? Testing doesn't tell you how to build your program, right? It can only tell you when you've broken something. It can't tell you when you've gotten something right. So you have to understand your program. You've got to deal with this complexity, all right? That's very related to symbol and complexity. Okay, so values versus references. You know, I might even skip that. I'll go into it. Amounts of complexity. Okay, so values are data. Values don't change, all right? The reference is the thing that's pointing to the data. So if you have an array and it has 3 strings in it, it's got like A, B, and C, and then you add D to it, you didn't change that. You didn't change the original array, right? You didn't change that value. You made a new value. You made a new value. Maybe the reference is pointing to the same thing, but there's a difference between an array of 3 things and an array of 4 things. You don't mutate them, right? They're different values. Different languages have different semantics for this and different meanings, and this is important in Clojure. I'll discuss this more in future slides. Oh, okay. Often these things are complected. They're often treated as the same, but they are not. And I will argue that you will benefit from distinguishing between them. Okay, definitions. Watch the videos is what I'm trying to say. All right. Okay, so now easier, less theoretical definitions, okay? So programmers are so good at naming things, right? Who loves the acronyms, right? Okay, so there's a lot of this, and you have to understand it. So, okay, so Clojure with a J, they're all pronounced the same too, right? Okay, so Clojure with the J is a language that targets the JVM. When was it invented? 2008, 2007, something like that. It's been around for a while. Clojure is a language that targets the JVM. ClojureScript is a dialect of the Clojure language that targets JavaScript. This talk is called Why ClojureScript, right? So Clojure the language and ClojureScript the language are the same thing, right? They only differ at interrupt points, and I'll discuss what that means future in a minute. But just understand that it's the same syntax. It's the same syntax, all right? The Google Clojure compiler, that's Clojure with an S, is involved in the ClojureScript compilation process. Okay? So the Google Clojure library is this open source thing that Google released to the public a couple years ago. And And this is what they use to build Gmail and Google Maps and Calendar and such, right? It doesn't have big adoption in the JavaScript community. Raise your hand if you use the Google Clojure library. Yeah, one guy, right? Two guys. The ClojureScript people use it, right? But this is you think of it like a combination of jQuery and jQuery UI. Who's used those things? Hand shoot up. Okay, so these are JavaScript libraries, not to be confused with Clojure, the language. And then a Clojure is a computer science concept, which we're not going to discuss in this talk, but I just wanted to throw that up there. So all these projects are named after that in the most confusing way possible. Okay, so why a language? Not even Clojure, but why would you even consider a different language? Does this work now? Yeah. Okay. So I say hello and you say hola. Does it mean the same thing? I don't know, it depends on the context. All right. I love this quote. It's an excellent quote. So a programming system has two parts. The programming environment is the part that's installed on the computer, right? And the language is installed in your head, right? And the meaning, the idea here is that, and then kind of a theme of this section of the talk is that we think in terms of the languages that we know, right? That is just, I believe that to be universally true, and I'm going to try to convince you of it in the next 3 slides. Okay, so languages matter, right? They have opinions and defaults, and these opinions and defaults inform the decisions. So Perl, there's more than one way to do it, right?
Most of them are wrong.
Yeah, most of them are wrong. Yeah. Python, there's probably one way to do it, and it should be idiomatic, right? Maybe the Ruby default is like we care about syntactic sugar and be friendly, right? I don't know. I'm not a Ruby programmer. I don't know what the JavaScript opinion is, right? But it kind of has it. The JavaScript opinion is use jQuery, right? I don't know. The Java philosophy is create nouns, right? So these are important, right? These are important because they inform how you're going to use your program. They inform the libraries you're going to use, right? What are some of the opinions of your favorite language? It's just a good question to think about. Okay, so unfamiliarity is not bad. So people are scared, right? What's the slowest thing to change in the world? Habit of mind, right? Changing habit of mind. So like, there are countless examples of this from history, right? Galileo discovers how planets work. No, you didn't, right? Nothing changes slower than habit of mind, even in the face of like positive counter evidence. People don't want to change their opinion, right? So unfamiliar, weird, strange. I don't know the syntax. I don't get it, right? These are not words of understanding. That doesn't mean you understand it and you chose not to do it. It just means you don't understand it, right? You can't kind of stand there in ignorance and talk about something, right? Charlie Munger, who is Warren Buffett's business partner, has this great idea about the work required to have an opinion, right? Where like you have to have done work in order to have an opinion on something, right? And most people's opinions about things aren't valid unless they've sort of done that legwork, right? So are you focusing on the concept? Are you focusing on the concept of the artifact? So I really like my syntax, and I really like C-style syntax, and I've not used a language that doesn't have syntax similar to C. Does that have anything to do with the artifact, the thing you're producing? No way. It has everything to do with you sitting there typing it, right? That's a construct idea. You shouldn't let that idea influence your decisions about the artifact, which is the result, which is the thing that matters, which is the thing that customers care about, and you should care about. More language concepts is more power than language. I don't really have time to get into that, but Paul Graham's essay, Beating the Averages, is a great example of this, right? So how powerful is your language? Again, a purposefully open question to kind of get you thinking about this. Okay, so blank is a stateful, dynamically typed, imperative programming language often used in web development that supports an object-oriented programming style. What is this? Anybody? What group are we at? JavaScript, right? PHP, Python, Ruby, Perl, right? What else am I missing? Okay. If you take out the dynamically typed part, you can add Java, C++, C, C#, right? So all these languages are remarkably similar. They're far more similar than they are different. But people love to talk about the differences. Oh man, you're You have to deal with semicolons? What are you talking about? No, you have the same, you are using the same concepts. You are building your programs, you are governed by the same rule set, right? Change your language, change the way you think about your programs. The language influences the way you think about your programs. I can't overstate that enough. All right. Okay, so that's why you should care about language. And why should you care about ClojureScript? I need to hurry. Okay, so remember I said languages have opinions and they have defaults. Clojure is overly focused on simplicity. And simplicity in that meaning that I said on the second slide. Not easiness. Right? This is not library.do the thing I want. It is simple. It's the notion to pull something out and understand it without it being connected to 12 other balls. Because you can't juggle 12 balls in your head. You can juggle like 3. Right? Clojure is a success story on the JVM. So Clojure has been on the JVM longer than it's been on JavaScript. It has been adopted by some Java programmers. It is completely considered a success story on the JVM. Nobody is saying that Clojure is a dead language, right? It's got this thriving, vibrant community that's done amazing things. It's absolutely a success story. And it's the same language as what I'm talking about here. All right. Functional programs are easier to reason about, and they result in fewer lines of code. This was proven in like the 80s, as much as you can prove a thing like this with some Erlang studies done at Ericsson. And like the programming community just never read those papers or like doesn't want to believe that, right? But functional programs are I can just tell you from personal experience, they're way easier to reason about. For all the reasons I'm talking about, they have defaults. They have these opinions that make things simple. These are two of the things that make things simple. So data is immutable by default. Remember the idea of a value and a reference, right? You don't create a value and assign it to a thing and then change that thing. You have a value, you have a different value, right? And maybe you don't even need references. Maybe you just program with values. Maybe you can always be confident of what a value is, right? Data is mutable by default. Pure functions are the default. So who loves a pure function? Everyone should have their hand in the air. Everyone should have their hand in the air, okay? A pure function is a function that has no side effects. It doesn't depend on state. You can run it at any time. You could run it 2 minutes ago, or 100 years from now, or right now, and it's always going to produce the same result. It doesn't depend on disk. It doesn't depend on like that row being in the database. It doesn't depend on the network, right? Reliable programs are built of pure functions. Pure functions are the building bricks of reliable programs, and you should love them. By the way, you can write them in any language, right? But in Clojure, they're the default. Isn't that nice? Isn't that nice, right? Okay. Clojure has an excellent approach to state management, which is a first-class problem in UI programming. And I'm going to show you that with code, okay? Macros allow for extension of the language in a powerful way. This is also a little opaque and difficult to explain in my little 45-minute talk. And I'll show an example of this, but this isn't just adding a library and getting the functionality of that library. In Clojure, in any Lisp actually, you have full control over the syntax of the language at the language level. Again, that sounds a little strange if you've never written this way before, but just understand that there's a difference between this and a library. Let me give you a quick real-world example of this. Core.async is a Clojure project. It was written like a year or two ago, and the core developers wrote it, and it's methods for dealing with asynchronous programming. So if you've ever used a jQuery promise, you've done this sort of programming, right? Who's ever written an AJAX request in this room? The hand shoot up. Okay. So it's tools for dealing with this. They wrote this macro library for the JVM and also for ClojureScript. It's the same library. Okay? That doesn't happen. Right? That's only possible with macros, right? Only possible with macros. But okay, so it has all of the benefits. So this is the first time I've mentioned JavaScript as a compare, okay? It's got all the benefits of JavaScript, every single one of them, and it has none of the problems, right? There's nothing that you can do in JavaScript that you can't do in ClojureScript, arguably better in ClojureScript. You have 100% access, all right? It compiles to JavaScript, right? So you can use it anywhere, right? I don't need to tell this group that JavaScript is the world's most popular programming language installed upon billions and billions of devices with the 3 or 4 biggest tech companies in the world pouring millions of dollars at engineers to make it the fastest engine on the planet. I don't need to tell this group that, right? Because we're here at the HoustonJS meetup. But ClojureScript targets that platform. That's a platform I want to be on. Right? Okay, you've got simple access. I use simple, not easy, to JavaScript libraries and ecosystem, right? ClojureScript has real namespaces, right? And that brings sanity to code organization. So, JavaScript was invented in like 94 or 96, something like that, mid-90s, right? We went a decade plus with no namespaces, right? Now we have AMD, CommonJS, Google Clojure library's got a namespace system, YUI3 has a namespace system, Node's got a namespace system, there's the require.js library, and then ES6 has some proposal for namespaces, right? This is insane. And they're not even real namespaces, right? They're a bolt-on to the window object, right? We're using JavaScript objects as the namespace, okay? It is crazy. And it's not, and you might say, oh, well, my shop adopts AMD. All our modules are AMD. Well, is the library you're integrating with AMD? I don't know. Is the next job you go to going to be AMD? Or are they going to be CommonJS? Is there going to be a conflict there, right? So this brings sanity, right? It really is crazy that the language doesn't have namespaces, and they bring it in a real way. One of my coworkers said, she doesn't speak English very well, and she was like, it's so nice, the code is always where it should be. Ah, that is nice, isn't it? Right? I know where to find it. Okay, whole program optimization is a killer feature. I'm running out of time. Everything, so you write ClojureScript, and you got namespaces, you have all these ClojureScript constructs. ClojureScript constructs. The output of ClojureScript is optimized at the whole program level. That's very opaque. I'll show it in a slide. But this is a killer feature that you can't get otherwise. This deals with compression, minimization, dead code removal, and the use of libraries. These are important things. Same language client server. That's really true for JavaScript and Node if you're using Node. But with ClojureScript, or Clojure rather, you have another option. You could write a library in Clojure, and you could run it in the browser in ClojureScript, on Node.js in the server in JavaScript, or in Node, or on the JVM as Clojure, right? So you get the same thing. All right. So first questions for JavaScript developers. Every JavaScript developer has asked me these questions, right? Can I use jQuery? Like, it just blurts out of their mouth before I can even finish the sentence, right? And I know that you were thinking that when I said this, right? So I have an answer for you. I have the answer for all these, right? Can I use whatever was on Hacker News on Tuesday, right? Can I debug? I need debugging, right? Yeah, you can. Okay? Yes, you can. So I just want to get that out of the way, all right? So if you're thinking, well, I'm not going to use this because it doesn't have jQuery, you're wrong, all right? Okay, so I mentioned earlier about immutability. This is a difficult concept to explain, especially in slides and especially without writing code. I'm going to try anyway. Remember the definition of complecting. Complecting is taking two things which could be distinct and combining them. Right? Combining them. So A, and assume that the var, these are defined. Right? This is not bad JavaScript. So A is the string foo, and then B is the simple object. And then we're going to run some fun on A and assign it to A, and then we're going to run another fun with A and B. Right? This is simple, right? Right? What's the value of A here? What's the value of B? You don't know. You don't know. You can't know, right? By definition. Maybe it's foo. Maybe these functions didn't change A at all, right? But the point is that you don't know without the context, right? This is regular JavaScript code. You write this like every day, right? But you don't know without context, okay? Mutability complex value over time. Try to say that again. That's a tricky concept. Mutability complex value over time. Remember what a value is. Values don't change. They're a pure thing. They're like data. Like foo is a value. It's a string. All right? The value of something depends on what time it is in your program. Time is another ball that you're juggling in your complexity world. Oh, what time is it in your program? Oh, that happened before this or after this? Right? If some fun is a pure function, you don't care when it happened. Right? So this is mutability. Right? What's the value of A? What's the value of B? You don't know. You don't know. Again, this seems opaque. I can just tell you, I've been programming JavaScript for a minute, and I've written a lot of JavaScript. When you program with immutability and values, it is so nice. It is so nice. You trust your code. When you're programming with values and immutability, it seems irresponsible to program with mutation. When I go back to code that's stateful, it seems irresponsible. That's the word I would use. Okay, more on state immutability. So the DOM is stateful. Sorry, you don't have a choice. It has to be, right? So how are you going to deal with that? Our UIs are stateful, right? This box, this window is showing. Now it's not, right? Oh, I'm on this page. Now I'm on this page. This text field has stuff in it, or it doesn't, right? So I think that in UI programming, UIs are inherently stateful, right? And as far as I know, and this is a source of huge bugs, right? Almost every bug is some function of mutability, right? Oh, well, it's supposed to work, but the database had the wrong value. Oh, okay. So, like, who thinks that? So global variables are bad in JavaScript, right? What's a database except a globally mutable data store? That's exactly what a database is. It changes state over time. What's the value in this row? What time is it? At 3:30, it was 4. Now it's a string of, barf or whatever, right? Okay, so when you're dealing with state in the UI, you can really there's only two approaches that I'm aware of. These are patterns. These are like programming design patterns that people use. For lack of a better term, I'm going to call this the backbone model and the angular model. Because backbone and angular are real popular. Raise your hand if you use one of those, either of those, right? Yay! Okay. So the backbone approach is to essentially wrap around state. So here's this thing, and so this is this thing, and it's stateful. And tell me when it changes. So enter it via a method, and then I'll watch it. But you have to enter it with a method. If you set it directly, that doesn't work. So you got to make sure that you tell me, right? And also tell me when you get it, because I have to know, or the thing doesn't work, right? That's the backbone approach. The angular approach is to say, well, let's establish a relationship, like a data binding, right? Angular is really just a flavor of FRP, of functional reactive programming. And that's like a language thing you can read about on Wikipedia. The Elm programming language is supposed to be FRP. I don't think that either of these approaches, taken wholesale, makes any sense. Right? I think it's absolutely context dependent upon your application. I think that some things you want to manage the state, and other things you want to set up a binding. I think that if you're like, I'm going to build an Angular app, I'm going to do all binding, I think you're going to get into real problems when you need to do real simple state management. I think you're going to be storing it in the DOM, because that's real convenient. And I think if you go the backbone route, you're going to have either problems with performance on things that need to be set up as binding, or you're going to create a ton of state all over the place, right? And it's like, well, where do I find the thing that changes the thing that's on this page? Because these two things are connected, right? So backbone is almost by definition complecting state with your program. All right. Remember, I made this distinction between libraries and things at the language level, right? And remember that languages inform the way you think about your programs. Clojure deals with state at the language level, at the lowest level. This is not a library. We don't import my state management tool, right? It is dealt with right there, in the weeds, in the thick of it. So again, this is kind of opaque, right? This is real-world Clojure. For the people who know ClojureScript, raise your hand if you know the syntax of Clojure. You'll know that this is actually missing some key things. I left them out for clarity, but this is totally the ethos of Clojure. Okay, I'm going to define foo. I'm going to call it an atom. An atom means it can change state. I'm initializing it at nil, which is like null. All right. Here's a function called onChangeFoo. It receives the old foo and the new foo, and it does something, right? I'm going to watch the atom for changes. Add watch foo, onChangeFoo. Again, this is not a library. This is part of the language. That you get this with atoms, okay? This means that onChangeFoo is going to run every time we change foo. And in order to change foo, I have to give it a pure function. So that's what swap does here. So in Clojure, when things end in an exclamation mark, it means it has a side effect. It means it's not pure. So we're going to execute the bar function. The result of the bar function gets put into the value of foo. Is everyone following this? This is backbone in 4 lines of code. That's what this is. It is, right? Okay. So this is just one example of state management in this language, right? One pattern. I'm not even going to show you like the FRP patterns. I don't have time. Okay, so I just wanted to show you an example of JavaScript interop in a macro, right? So this is event handling. You guys know what event handling is? where you put JavaScript events on some container and then they bubble up. So we're just putting these events, we're using jQuery, right? So you don't need to understand the syntax to know what it's doing, right? Hopefully that's the goal of this slide. This is to show you that this is exactly what you'd be writing in jQuery, right? There's no like, that doesn't look weird. Or sorry, that looks, maybe the syntax looks strange, but what that code is doing, that's bread and butter every day for a JavaScript dev, right? It's a weird syntax, sure. I'll accept weird as an adjective here. Okay. There's a macro there too. I'm going to just gloss over that for time. Okay, values are great, right? So we use objects as maps all the time, right? We do this all the time in JavaScript, but they're not. They're not values. They change, right? And where are they? I don't know. Who's ever been bitten by a copy bug where you write in JavaScript? If you don't have your hand raised, you haven't written enough JavaScript, right? But the copy bugs are nonsense, right? Why can't I do this? Why can't I compare A and B? I should. I just check the properties in these are right. I should be able to check the properties. Those are strings. I can do equality comparisons on strings. I should be able to check number equality. I should be able to check object property equality, right? Why can't I do that? Why am I? And also, by that matter, why am I limited to strings as my object keys? If I have this idea of a value, if I always know what equality is of a value, why am I limiting myself to strings? So this works, right? And you can take a value and you can store it in an atom, and you can watch its state change over time. The implications for that for UI programming are real powerful. That guy's nodding his head, he gets it. Yeah, okay. So this works, you just equal. Does it equal? Yes, no. It would never be equal, right? Because they're not the same. But you get that for free in the language. You don't have to write any fancy equals code to get that. Values are awesome. Programming values is great. Okay, this is whole program optimization. I promised I'd show you this. So here's some code. It's a function, it takes an argument, and then we print it. Right? Real simple. This is like white space. This is what Uglify is doing. Who minifies their code? Has like a build step. Wow, more of you need to do that. All of you need to do that. If you don't have your hand raised, you're doing it wrong. Okay. So this is minification, right? So we saw that name is only used in this scope, so we could safely rename it to A, right? And then we just removed all the white space because we don't need to, okay? But this is what the Google Clojure compiler does in advanced mode. This is like when you look at the view source of Gmail, it's just like ACQ5, or not 5, but like QK, right? That's this happening. This is advanced compilation. This is super cool, right? It saw that we were calling this function once with only one argument, and it just inlined it. Super cool, right? It is insane. That's right. Insane is the correct adjective for that. This will remove code. So I don't like have interactive, but if you add a function and you don't call it, it'll just rip it out, right? So it actually builds an abstract syntax tree of all your JavaScript and it compresses it. This means if you add a library in ClojureScript, you add a big library in ClojureScript and you use one function in that library, this will rip out the rest of it. That's a big deal. That means that, right, it's especially a big deal as your program grows, right? Because you can add as much as you want, and the dead code will just get ripped out. It's going to be as small as it could conceivably be. All ClojureScript that you write, and you have, in order to get this, you have to write your code in a special way, right? Like you can't write regular Java. You've got to, and Google does this, right? Like Google enforces their engineers to write their code in this really constrained way. Everything that you write in ClojureScript gets emitted in that way. So you always get this with any ClojureScript program. Very cool. That's a killer feature. That becomes more important as time goes on. All right, so that's, okay. So why would you not use ClojureScript? There's no free lunch, right? I'm obviously a big fan of it, all right? I'm a proponent of it, but you've got to show the other side of the coin, okay? So it requires a build process, or you can't just like push CLJS files to the browser, right? It's like, no, you have to have a build process, okay? So you've got to be, the build process is not painful. It's just like, if anyone is familiar with Grunt, it's something you run in the background, right? So I am typing and I press save and then I press refresh, and usually by the time I've gotten the browser, the editor window to the browser window, the compilation process is done and the code is ready to go. So it is required though in a way that's not with JavaScript. You can't just throw it on the page. there's a standard library you get with ClojureScript, right? And it has a size. It doesn't have a big size, but it has a size. So if you're very, very concerned about size, then ClojureScript may not be the tool for you. But again, that's relative, because as your program grows and you're adding libraries, that whole program optimization might kick in and be better than regular minification if you're just doing JavaScript. If you have a large content-based website with minimal interactivity on each page, so that's Craigslist, Amazon.com, probably you don't want to do this, right? Because obviously you don't need a lot on the client, right? You might want to use it on the server, though. No reason why you couldn't use it on the server. Okay, tooling is young. It's not non-existent. It's just young. So there's not a huge community. That actually, depending on your perspective, that actually might be a pro. All right, that might be a good thing. Because with big communities, you know, it's hard to separate the wheat from the chaff. The Clojure community is a really great community, though, right? So like a lot of really cool people are in the Clojure community. Initial setup can be difficult, especially if you don't have somebody there who's kind of helping you out, right? So I would recommend if you're gonna do this, try to find someone with experience and have them push you in the right way. They can save you many hours because you did .clj versus .cljs, like that guy in the orange shirt did. I obviously I think the positives outweigh the negatives, but these are negatives of ClojureScript. Okay, and I went to a training by Edward Tuff, right? And he recommended not doing Q&A in audiences more than 20 people. So, but I'll do some questions. I'll do like 3 questions, right? But anyway, that's the talk. The slides are available if you want. So I'll take like 3 questions. Or no questions. Go
for initial setup, is there like a Yo? Do you use Yeoman to do that?
Are you familiar with line again? No, not at all. So I think Jared's going to talk on this. But don't steal content. Yeah. I said it's difficult. I didn't say it was impossible, right? It's not hard. You just need to install Leiningen and do and set up your project.cl. There's a thing called project.clj. It's the spiritual equivalent of package.json for like a node project. You just have to set that up and run line, get everything, and it just gets everything. It's not hard. It's not hard. Questions? No other questions. Wow. I just bored you all because everyone's asleep right now. Yes?
All right, the Google website indicates that you can use the Clojure compiler on any JavaScript.
Yes, okay, you can. You
You
can.
don't have to be writing the Clojure construct.
That's correct. That's correct, yeah. Yeah.
But you can add to your JavaScript library as you learn about Clojure. I recommend that as a practice.
So I think there's, is your question about the Google Clojure compiler?
Yes.
Okay, so let me explain how that works, right? This is orthogonal to ClojureScript. This has nothing to do with ClojureScript, right? Google released this in 2009 for their own internal use, and then they made it public. The Google Clojure compiler is a minification tool. It is like Uglify or the YUI compressor. It's got 3 modes of operation: simple mode or white space mode, simple optimizations, and advanced optimizations. Any JavaScript code is safe to be put into white space optimizations or simple optimizations. 99% of code works well in simple optimizations. For advanced optimizations, though, it will rewrite all your damn symbols. Okay, and so that's what they're talking about, right? What I'm saying about ClojureScript is that when you're writing in ClojureScript, you're writing it in ClojureScript. It goes through a compilation process, which you're not involved with, right? You just press the button and it goes. The output of that compilation process produces JavaScript, which is consumable by the Google Clojure compiler in advanced mode. Does that answer your question? Yes. I think Jared is going to talk about this.
Yes.
No more questions about Jared's content.
That's a whole slide. Gone.
Damn. All right. Is there any other questions? Wow, that was like silent. Yes. Yeah.
All right.
Last question. 3 questions max.
So you mentioned a lot of things where one of the big benefits of programming with style is avoiding mutability and some other things.
Yeah.
Can you show us swap?
Yeah.
You seem very closely related.
Yeah. So okay. Yeah, absolutely. Right. So let's look at that slide. Okay. Because that's absolutely mutation. That's state. Right. Where is it? Here. Right. So foo is mutable. straight up, right? Like I'm not saying it's not, but it's not. You know, so you see the ceremony around it, right? You didn't just change it. Like so, compare changing of foo here to what's happening here, right? That's the distinction that I'm trying to make here. So it is just ceremony around, but what this does, this separates the notion of a reference and the notion of a value. You can be confident that foo is always some value, and that the reference to foo is independent of that value. And the way in which you change it, so this has to be a side effect free function. Bar has to be a pure function, right? So it is mutation, absolutely. And I'm saying that in UI programming, state is a necessary evil of UI programming, right? I'm not a fan of pure functional languages where there's no state, right? Like that's nonsense, right? Well, for UI, right? No, I don't think Haskell you have to wrap your I/O in a monad. No, that is nonsense, right? That's nonsense. Clojure is again with its defaults and philosophies, it's a very simple language. It's also a very practical language. So anywhere I want, I just console log, what does this thing look like? And I can do it. So you can write in a mutable way in Clojure or ClojureScript, but you have to go out of your way to do it. It's not idiomatic and it's not the default. The language tries to push you towards not that. So does that answer your question? Yeah. But yeah, absolutely that's mutation.
But there is a library that you should never use.
Okay.
You can do it.
Okay, boom. All right. That is all. You can reference these slides. It's open source. I'm Chris Oakman. Thanks for playing.